We have a new group member joining us today.
We do.
She'll be observing.
He was showing us Isabel.
Oh, dang it. Show me again. It's so bad. Oh, it's so cute.
She had a long night tonight.
You get extra credit for that.
Huh?
You get extra credit for having a cute kid.
Not from the teacher, just from Susan.
Oh, yeah, that's actually in the broadcast too. I didn't even think about that.
Okay, let's get started.
Okay, so as a team, solve the system of equations using elimination, Gaussian elimination.
Gaussian.
So we'll just solve for a variable, then plug that into the equation, and then check it.
I thought that was when you eliminated a variable.
Oh, maybe it is. Is it the same thing as addition?
Yeah.
Okay, then yeah, never mind. That's what it is. So we could, yeah. So what do you guys want to multiply this by?
Let's multiply the top one by 4.
By 4. Cool. Negative. Oops.
(25/11).
Huh?
Did you get 25/11?
Yep.
Okay.
I love it when it goes fraction. And then for elimination, do we actually have to do it again? Do we actually have to do elimination for y, or can we just plug in x into one of the equations and check?
Yeah, plug in x.
Okay, cool.
Like calculating.
It's going to be 44/11 minus 50/11. Y equals, so what, -6/11?
(6/11).
Is that -6/11?
Yeah.
So you got 2?
Mm-hmm.
So then if we plug that back into, so if we did 2 times 25 divided by 11 plus -6 divided by 11, we get 4. Yeah, so it's good. Cool.
All right, next.
Okay.
X
So
equals 6 minus 1. X plus 3. Y equals 4. Do we have to use elimination?
yeah, it looks like it.
Okay.
Top by negative, what do you want to do, -3 or 2?
Let's see. Let's arrange the first equation first so that it.
Yeah.
Yeah, so it's, oh yeah, sorry, so it's x plus y equals 6.
Yeah, plus y equals 6. And then, which one do we want to eliminate? Oh, it's going to eliminate both. There's no solution.
Wait, so if it eliminates both?
Yeah, if we multiply by -3,
It would.
it eliminates both, and then they equal different things.
Okay.
So it means no solution.
No solution. Okay. Cool.
So the lines are
Oh, you're
parallel.
right. I have a 2 there instead. My bad. Okay. Cool. All right. So C. We want to get.
Minus
Sorry.
2y. And let's just rearrange it. So -1/2 x plus y equals 3.
Do we want to get rid of the fraction?
Yes.
So we multiply that by everything by 2 on the bottom.
Mm-hmm. And then it's just going to be -x plus 2y equals 6.
Well, and it cancels out everything again, huh?
Yeah, but this time it cancels out the -6 and the 6.
So it's all 0 equals 0. So one solution. Or
Yeah, so it's going to be the same line or dependent.
oh yeah, dependent. Okay.
So we have independent, inconsistent, and dependent.
Yeah.
And then for the dependent one, the equation is just going to be y equals. Should we do it like that? Y equals. I guess we don't have to.
Well, yeah, I'm not sure. I'm not following. How you thinking?
We just have to put the equation line. So let's just put x minus 2y equals -6.
Okay. So A times B. We've got what is that's a 3 by 1 and a 1 by 3.
1 by 3. Yeah. So we can do this one.
Mm-hmm.
Two times 2 is 4. Okay, so this is gonna create a 3 by 3. Am I right?
Yeah, 3 by 3.
Okay.
So
The top row is gonna be 4, 6, 8, right?
yes, yeah, 8.
Okay, I just want to make sure that I remember this right.
9,
-6, -9,
3, 4.
-12, and then 2, 3.
So what did you guys end up getting? 4, 6, 8, -6, 9, 12, 2, 3, 4.
When you said -6, 9, 12, you meant -6, -9, -12, right?
Yeah. Mm-hmm.
Okay. Yep, that's what I got. Okay, next one. B times C.
That's a
That's
1 by 3.
impossible, right?
Yeah. So yeah, that's a 1 by 3 and a 3 by 2. Yeah, not gonna work. B, B, C, 1. Oops, or B, yeah, 1 by
Possible
3.
because 1 by 3.
3 by 2. Also because the rows and columns don't match.
Yeah. If it was a 1 by 3 or a 2 by 3 and a 3 by 2, then it would work.
possible. Okay. I wish the rest were all impossible too. Okay. E, D. So E is a 3x3 and D is a 2x3. So we are good there.
Okay.
So ED. Okay, so 1, -4, 1, -1, 3, 5.
So you guys said that the BC one isn't possible.
Were we wrong?
The answer says that it is.
Really?
Yeah. Because I was just checking my answer for the AB, just making sure I got that one right.
Mm-hmm.
Because I was getting confused on that one on the homework on those ones. But it says BC is possible.
Okay. So is that because it's a 3 and a 3?
It doesn't tell me why. It just shows that it is.
Okay, it's each row of A must have the same number of columns as B, or I guess in our case
Okay.
CB. So wait,
Row has to correspond to column.
each row.
I thought it was
Let's-
column to
Maybe,
column.
maybe I have it written down wrong here. Because that is so B and C. B is a 1x3, correct?
Yeah.
And then C is a 3x2.
Okay. So rows to columns, so 3 and 3.
Yeah. Okay.
What I don't understand is that they end up with a 1x2.
Oh yeah. Okay. So we let's see. So right here, right? Can you guys see that? Okay. Yeah, I'm good. Well, anyway, I can't. If we were going to multiply a 1x3 times a 3x2. So we look at the two inner. We look at the 2 3s. That's how we know we can. If the two inner numbers match, we're good to go. And then the outer two numbers, that's going to be what it makes, right? That makes sense.
Mm-hmm.
So we've got the. Oh, where is it? Right here. We've got the 3s match. We've got the 2 3s on the inner part of that, and then on the outer part, we've got a 1 and a 2. So that's how we know it'll become. That's a trick I use. I don't know if that makes sense.
Okay.
But nice save on that.
Okay.
So that's going to be cut. So instead, it's going to be 2,
Then how do we multiply this to get the
2, 3, 4. So I think we got a 4, 5, 1, 0. So I think we'll be doing kind of like what we did on the other one. We'll do the. We're gonna get. So we got a 1x3, 3x2, and we want a 1. So I think. This is one of those where we have to like add some of the answers in that we get.
Yeah, probably.
So
That's the only way I can see that we would get the numbers low enough, like that number of answers low enough to the 1x2.
So we do something like 2 times 2, and then 3 times 2, and then 4 times. Oh no! Wait. Yeah, 2 times 2, then 3 times 2, then 4 times 2, and then 2 times 4, 3 times 4, and 4 times 4. No.
So the answer they got, multiplying them all out by each one, would be way too high of a number because they only have 20 and 21.
Okay, let me try to remember how to do this.
21, okay. Okay.
And we do have a 0. So that might factor into something
One times one.
here. Okay. So yeah, we do add. We're gonna do 2 times 2 plus 3 times 4 times 4 plus 1. Because we multiply the we're gonna multiply B times the first column of C.
And then you add the second column.
Mm-hmm.
So it's going to be 2 times 2, 3 times 4, and 4 times 1, and then adding.
No. 2 times 2 plus 3. Times 4 plus 4 times 1. So 2 times 2 plus 3 times 4 plus 4 plus 1.
Times 4. So one more time, that's 2 times 2 plus 3, 3 times 4 plus 5, 4 times 1 plus 0.
Why are you saying something about a 5? Oh, you're doing the second one. Okay.
Or yeah, maybe I'm just not following you very well.
Okay, so first we're using the whole row of B and the first row of C.
Mm-hmm.
We're going to do position 1 times position 1 plus position 2 times position 2 plus position 3 times position 3.
Okay, let's see.
So 2 times 2 plus 3 times 4. 4 times 1.
Oh, okay, there we go. That makes sense.
That equals 20. Then we do the same thing with the second column of C.
Times 3 plus 3 times 5 plus 4 times 0.
Mm-hmm.
Okay,
And that equals 21.
perfect.
And looks like that's the correct answer.
Cool.
All right.
Okay, and then E times D we can't do because there are 3 rows and 2. Wait.
3. Yeah, 3 rows and 3 by 3, and then a 2 by 3.
Yeah.
Yeah, so the rows and columns don't match.
Okay. A plus C. That's not gonna work, is it?
No.
A plus C. And it does not work again because of the rows and columns don't match.
Yeah.
By 1 plus.
With addition, do the rows and columns both have to match?
Yeah, I'm not sure.
I think so because they add straight over to the exact same spots
Yeah.
that they're in. So if you have a 3 by 3, every one has this goes from like the first spot to the first spot, second spot to second spot.
Yeah.
So I think addition does have to have the exact same size.
Okay, so this next one with subtraction is going to work because they're both 3x3s.
Yeah.
So we're going to do 3 times e. One, -4, 1, 3, 5, 2, 0. Okay. You done with that one?
Almost.
Okay.
Yeah, okay. I got 1, -14, 1, -3, 7, 13, 6, 0, 7.
Me too.
Yeah.
Now we'll do e times f.
E times F. And that does work because it is, oh, that's going to be a big one. So that's 1, -4, 1.
Okay, f looks like it's means something and I've seen it before.
Same.
So what are we anticipating having for the final structure? A 3x3, right?
Mm-hmm. And so for this, it's going to be kind of like what we did for that earlier problem. We're going to do 1 times 1, -1 times, or sorry, 1 times 1 plus
-4 times 0.
times 0 plus 1 times 0.
Yeah. So it's just going to be 1. Then we'll do that again for the second row. So 1 times 1 plus 1 times -4. So -3. Because it's also 1 times 0.
Wait. Yeah, okay, so then.
So I got 1, -3, -2. First row.
Mm-hmm.
Yeah.
Okay, then we do it second row, all 3 columns.
Wait, quick question. Oh, it doesn't matter. No, never mind. Okay.
Who has a question?
No, I don't anymore.
Okay. -127.
-127.
Yeah.
Okay.
Hmm.
All right, what are we getting for the last row?
I'm getting -275. No.
It should be, so 2 times, you don't have to think about the zeros at all, so it's just 2 times 1, so 2, and then the next one it's 2 plus 0, so 2 again, and then the last one is going to be 2 plus 0 plus 3, so that's 5.
Oh, sorry, I read you the last column. So yeah, yeah, I got 225 as well for the last row.
Yeah, 225.
Cool.
All right, that means that we are all finished. Do we want to do the quiz from last week now or on Thursday?
Well, I got class in about 20 minutes. Do you think we can do it in 20 minutes?
I don't know, because last week we had a little bit harder material. Or maybe that was 2 weeks ago. I'm figuring out. I don't know. Let's look at it.
Oh, quiz.
Yeah, let's not do this right now. It's gonna take a while. I mean, maybe we could just do like the first problem now.
Sure.
Okay.
Okay, here we go. Give the system of equal. Oh, wow. Holy cow! Holy cow! Okay, given the system of equations, determine what type of graph each equation presents.
Okay, so 1. Graph 1, first equation represents a circle, or it's an oval, I mean.
Sorry, it's a what?
An oval.
The first, because it's got the two. It's got the two squares in it.
And the second one is our bestest friend of all time, the parabola. Let's see. List the number of possible solutions when given the three function types you listed in part A. Okay, so if we have a parabola going through a through an oval, we could have 4.
Yeah.
Or we could have 2. Or we could have
5.
1 if it's tangent. Or 5 or 0.
Or 0, yeah. So
0, 2. Oh, wait, 1 if it only touches at one spot. 2,
2,
4. Wait,
5.
we could have 3.
1, 2. Yeah, we could. Okay. 3, 4.
5. No, we couldn't have 5.
Yeah, that's what I was trying to figure out. You can't have 5.
Yeah.
0, 1, 2, 3, or 4.
3, 4. Okay. So I'm gonna do some quick sketches of those.
Okay.
Okay. Some of these ovals look more like circles. Sorry.
It's all good. They don't have to be good because they're sketches.
How's that? Look okay? Look acceptable?
Yeah.
Okay.
They look way better than mine. Wait, how are we having 4? Let me see it. I know it works, but I can't draw it.
All right.
Because I'm not artistic. There we go. Okay.
Okay. See. Okay. D. Solve the system of equations. Can we just take the square root of both sides right off the bat for the first one?
For like just the first equation, you mean?
Yeah.
Yeah.
Yeah. So we should end up with x plus y equals 87 so far.
87.
9 times, because then 9 times, oh, nope. I squared 9 instead. Wait. Yeah, I'd square 9, right? Or would I square root it?
You're going to square root it.
Okay, never mind then.
So,
instead,
negative
3
4 minus 2, negative 6. So,
would be 9.
minus 6. 3 plus 6. Yeah. X plus y equals 9.
Is that it? Or do we need to actually solve for each variable now?
Yeah. We would need to find exact answers.
Okay, so then x is going to equal, or y is going to equal, so one of those variables is going to equal 9 minus one of those variables.
Yeah, let's do y
Y, okay.
equals 9 minus x. So then we're going to set 9 minus x equal to negative x minus 4 squared plus 5. Then let's just FOIL.
Wait, you're plugging this in back into the very first equation, right?
Do what?
You're plugging this back into the very first equation?
No,
Which one?
the second
Oh,
one.
so it's going to be x minus 4 plus 9 minus x minus 2?
No. So we did y equals 9 minus x, right?
Mm-hmm.
Then I plug that into the second equation. So 9 minus x equals negative x minus 4 to the second plus 5.
I am not following you. So
Look
what,
at
what
our system of equations.
huh?
Look at the system of equations.
Oh, you're plugging this back, you're putting this into the second equation of this is the, oh, I see. I thought you're putting this into the second equation, like after we had simplified it.
Yes, second equation of the system. Yes.
Okay, that makes more sense.
All right.
Y equals negative. Zero.
And then after we FOIL the x minus 4, it's going to be x squared minus 8x plus 16.
So x squared plus 16 plus 5? Or sorry, minus 16, I guess.
Negative x squared plus 18x minus 16 plus 5. Easily FOIL it. And with that, then you plug that in over here. Distribute the negative. That makes sense.
Minus 8x plus 16. Okay, so backing up just a little bit, make sure I'm on the right track. After you square that, the x minus 4, you're going to get x squared minus 8x plus 16, correct?
Yes.
Okay.
Then you plug it back in and distribute the negative.
Plug it back in.
You just like stick it in the equation where minus 4 was
16.
and get rid of the square.
So at the end, what did you get for your equation?
I got 9 minus x equals negative x squared plus 8x minus 16 plus 5.
Yeah, but
And then after that, I got negative 9 minus x equals negative x squared plus 8x minus 11.
11. So are we trying to get 0 on one side or no?
We're trying to. I guess we could do that.
I'm not sure.
Yeah, and then just solve it like a quadratic.
That's what I was thinking, but yeah.
Let's do that. So then we're going to subtract 9, add x. So 0 equals negative x squared plus 9x minus 20.
Oh, okay, cool. That's what I have too. And then that's going to be x equals
X.
-9 plus or minus 9 squared minus 4 times -1 times -20 all over 2 times -1.
Okay, so we need to use the quadratic formula.
And it turns out being just all that, if we plug into the quadratic formula, it ends up being just -9 plus or minus 1 over -2. And then I get -9 minus 1 or plus 1 is going to be 4 or 5. So I end up getting x is 4 or 5. Is that right?
Yeah.
Okay.
I think so.
Hey Connor, it's 9:54. I don't know where I got the 11 from.
I missed class. I think we can wrap this one up and then I'll take off.
Okay. Just want to make sure you aren't late for your class.
Thanks, I appreciate that, man.
Okay, so then we're just gonna have to plug in these x's to find the y's.
And can we plug that? We have to plug those back into one of the original equations, right? Or can it just be a simplified version of those?
I usually don't put it in the simplified just in case there are extraneous.
Gotcha. Okay. So then, which ones do we want to plug this back into?
Let's plug it back into the first one just to be safe.
First one. Okay. So then we're gonna get so if we get 4, it'd be 4 minus 4 squared.
So that's just 0.
Okay.
So y minus 2 squared equals 9. We can square root both sides. That's y minus 2 equals 3. So y equals 5.
5. Okay.
So our first set is 4, comma 5. Then 5 minus 4 squared, that's 1, plus y minus 2 squared equals square root 9. Or not square root 9, but square root everything. So 1 plus y minus 2 equals 3. Add 2, subtract 1, y equals 4. And so it's our solutions are 4, 5, and 5, 4.
Sweet. Yeah, that's what I got as well.
Okay. All right. Well, then we'll finish this quiz on Thursday.
Sounds good.
All right. Sounds good.
I'll send you guys a picture of the stuff later.
All right. Sweet.
Yeah.
Cool. Have a good night, guys.
Yeah.
Or a good day.
Yeah. Bye.